My name is Aaron DeYoung, and we are Arctiq. Today we have our Exploring Vault virtual event. Welcome. Thanks for joining us. We have a few things all over our channel, so please feel free to subscribe and like videos that you like. And let's just quickly go over how things are going to look today. So, who is Arctiq? We are a HashiCorp partner, full disclosure there, but we really like the stuff that HashiCorp builds. We use it in a lot of things that we do. Arctiq is a services-led firm in Toronto, Canada, and we focus on everything on the edge, cloud native, Kubernetes, and things like that. So, how this will go today, I'll just quickly cover the agenda, and we'll go over uh, some of the other things here. So we'll do some Q&A at the end of all three sessions. We'll have three presenters today, and then that's pretty much it. We expect this to take about an hour and a half, possibly two, depending on the length of the demos. But it looks to be a very interesting event today. So HashiCorp Vault is a tool for securely storing secrets and also managing secrets and there's both an open source and an enterprise offering. And the key features we have listed here, but I think the demos themselves will do the best for showing off how the power of HashiCorp Vault and what it does best. So we have three talks today, Tim Fairweather, Jacob Mammoliti, and Marc LeBlanc. And we're covering various topics from infrastructure to application and handling and management of HashiCorp Vault. So I'm going to bring in our first talk, Tim, and he's going to discuss secrets injection into Kubernetes. Hi, Tim.
Thanks, Aaron. Hi, everyone. And, I'll echo Aaron. Thanks for joining us. This is kind of an interesting time where we're all virtual. And so, we're giving the live YouTube stuff a shot and, hopefully reach a wide audience. So thanks again for joining. My topic here today is secrets injection into Kubernetes. So this talk is going to cover a couple of different elements of secrets injection in Kubernetes. It's going to involve some dynamic secrets. And for those of you that may have joined us last year for a live event, I've reworked what we did last year in a demo around dynamic database secrets in Kubernetes into what Vault has released recently in a native Kubernetes injection method. And so the idea was to kind of repurpose it. So I'll kind of go back and show you the code from last year as well and kind of contrast and compare the difference in how this works. So Kubernetes secrets aren't secrets. So maybe that's not a secret at all. And pardon the puns, but the idea is here that Kubernetes secrets are really just an encoded config map, let's call it. So they're somewhat obfuscated. They're disconnected from config maps, allowing you to do things like RBAC controls that are separated from the actual config maps that you might run your applications with. But at the end of the day, administrators, specifically cluster admins, and folks that you allow access from an RBAC standpoint to manage secrets can retrieve them and decode them. So, they're not terribly secret in the end. And a traditional challenge is, how do you actually manage secrets in Kubernetes? And what's the right way to do it? How do you integrate with Vault? Whether it's Vault something you've rolled out today or plan to roll out. Generally speaking, a common regarded thing is secrets management Kubernetes can be difficult. The idea here in the demo I'm going to show you is it doesn't have to be. So in particular, I'll go through a brief sort of introduction of who I am, and then we'll kind of go into the particulars of the actual demo itself. So my focus here is really around microservices and pipelines, kind of all things automation. I kind of state here, effectively, I kind of have this belief that, nothing should be manual, and we can automate a bunch of stuff and we can make things easier and, kind of streamline deployments and that sort of stuff. And specifically, I've helped, customers adopt secrets management strategies that involve HashiCorp Vault. Part of that is, API retrieval methods and, rolling things into Kubernetes as an example, which is what I'm going to show today. So the idea here, Vault secrets injection. So this is a new release from HashiCorp. It's effectively a refactoring of Vault Agent to basically bury in another technology from HashiCorp called console template. The naming around console template is a little bit weird. It really has nothing to do with console itself. It's a technology used underneath the hood within console that can be leveraged to template out config files using key value maps from a console database, as an example. The way Vault uses that is effectively the same sort of methodology, spinning up templates, but instead of templating out key value from console, it's templating out secrets retrieved from Vault. The nice thing is too, is it can handle the lease rotation and renewals and all that sort of stuff. So effectively, this new Vault agent or secrets injection is a combination of the two of these technology. Vault agent effectively to log into Vault, retrieve a token from Vault that allows you to retrieve secrets. The other piece is console template, which is going to allow us to template out our secrets for our application to leverage. This is all done through a mutation webhook controller. And so the idea of a mutation webhook controller in Kubernetes is this Vault injection controller is going to listen for pod events. Specifically, it's going to listen for create and update events for pods running in our cluster. And the idea behind that is it's going to watch for these events and it's going to look for a specific set of annotations. If it finds these annotations, then it's going to go ahead and rewrite the definition for our pod while Kubernetes is scheduling it. What this does for us is allow us to have Vault manage a bunch of the sidecars and things like that that are required in order to deploy and manage secrets from an application standpoint in Vault without us having to do this manually. So all of this is auto-injected. There's a couple of components to it. One is this is going to inject an init container that's going to fire up before our application pod. The idea behind the init container is this init container is going to do a pre-retrieve. So it's going to log into Vault and do a pre-retrieval of the secrets into the container or into the pod. Now, the pod itself is going to have a sidecar container with this same exact spec. The idea is the sidecar container will keep renewing, and it'll keep renewing secrets and keep renewing the auth in the Vault to make sure that we constantly have access to the secrets that we need. Custom templates are available inside of this whole architecture as well, so we can rewrite the secrets to our application container any way we see fit, any way we need for application to run. I'm going to leave this in here. I'm not going to go through it in terrible detail. Part of it, this is probably incredibly difficult to read, especially over YouTube. But this presentation will be available. The recording will be available, so feel free to follow up. The idea is this is using the Kubernetes auth method. And a very long story short, effectively what this means is our ability to create definitions in Vault to create a trust relationship between our Kubernetes cluster and Vault. Then inside of Vault, we allow access to secrets, or actually allow access to retrieve Vault tokens via a combination of service accounts in Kubernetes and namespaces. So the combination of those two allow us to actually log into Vault. And this purely takes care of the auth method pieces. So we don't have to do anything separate like app role. We're not going to use username and password. It's incredibly secure, revocable, all of it controlled at the Vault level, which is part of the power of Vault. The next part here is the actual retrieval of secrets. So this works in a couple of different ways. This is effectively a flow diagram for console template. But at the end of the day, what we're doing is we're retrieving secrets from Vault. We're writing them into a template. That rendered template is then available for our running applications. So this is what I'm going to show in the demo. Actually enabling this is a fairly straightforward exercise. So what I'm showing here is some of the code required to get this online. And this is in order for us to enable the Kubernetes authentication for Vault. So specifically, we're going to enable the auth method. We're going to go and configure it, which is effectively us registering our Kubernetes cluster to Vault, creating that trust relationship. You'll notice here that token reviewer JWT that's at the top of this is nothing more than a service account, or sorry, a token associated with a service account that we pre-create in our Kubernetes cluster. That account has no other permissions other than token reviewer permissions. So this is what's used to actually authenticate into Kubernetes, or into Vault, I should say. Then we write out a role. And this role is that namespace and service account definition combination. And what we're doing is we're saying here, our service account default in the namespace called Postgres client is attached to a policy that we called prod-Postgres. And then we set a TTL. So the next piece of this is the actual Kubernetes injection. So Kubernetes injection is done at the annotation level inside of a pod spec. So this can be buried into deployments, stateful sets, daemon sets, whatever deployment method you need inside of Kubernetes. The annotations allow that webhook controller to pick up on the change and then render out the secrets as we see fit. And so we can see here we're doing a couple of things. One is we're specifying agent inject equals true. So we're saying we want to inject secrets into this container. Then we're defining a secret that we're going to retrieve. In our case, we're going to retrieve a database creds read-only secret. What this maps to is a specific secret that we've lit up inside a Vault that's a dynamic database secret. So this is Postgres. We've created a service account inside of Postgres that Vault can manage and create other service accounts that we're going to use for our application. Then we go ahead and we render the template the way we want. So we can see a couple lines below there that we're defining a template here. And this template is writing out what Postgres is expecting in our app, which is a PG pass file. Not necessarily something we'd see in a live application, but it works for demo purposes to show that we can log into our Postgres database from our demo application. Then we can run arbitrary commands. So we can see here the inject command that we're passing. So for us, PG pass needs to be set with a specific set of permissions. Otherwise, the Postgres client will complain. So effectively, once the secrets are rendered, we're going and running a customized command to change the permissions on that file. Now we go and render out a secret here. This is for our purposes in logging, so I can show you that the secrets are actually working. And then the last two config items here are auth path and role. And this is how we tell our running application where to find its secrets inside of Vault. All of this is controlled through policy, so I can show you the backend policies as well. But the idea is everything is very tightly controlled, and effectively we can control all of this from Vault standpoint. So the actual Kubernetes cluster itself is a straightforward GKE cluster. Nothing terribly fancy here. It's a 3-node cluster, standard 2 cluster, I believe, inside of our Northeast 1 data center inside of GCP. So again, nothing special here. It's not terribly busy, obviously, because it's just for demo. But the idea was I wanted to kind of showcase what was running in here initially. So there's no, secret sauce, no extra things running or anything like that. We have Cert Manager here that's managing front-end certificates for our actual application. Then we have console for backend storage for our Vault cluster. Then we've got a Vault cluster as well as our Vault agent injector. So our Vault agent injector is this injection method. So this is a pod that's actually listening for other pod events in the cluster, listening for those annotations and rewriting our pod specs. But we notice we don't have our actual client app in here. Our client app is going to be called Postgres-client. What I wanted to do was actually do this live and show some of how this integration actually comes together. So one of the things I'll show you is in our Vault instance here. It's a pretty plain vanilla Vault instance. We've got the database secrets engine up, and then we've got access, and I can show you here that we've got no current leases. So effectively, there's nothing running from a Vault standpoint. So now we're going to go and we're going to actually deploy our app. I'll deploy it, and then I'll show you what's actually happening in the background. So with our app deployed, I'm going to show you a little bit of the actual code itself. So this is what our application code looks like for our client. It's pretty straightforward, very small app. All it's going to do is actually connect to our SQL database and on a 30-second loop, spit out some information. We're doing a quick query against a sample database here with nothing more than some census information with cities and countries and that sort of stuff. Same as the demo I did last year. So again, I wanted to kind of recreate that. To take a step back into what happened last year, I'll first show you kind of what's happening in the actual application itself. So if we have a look at our client app and have a look at our logs here. And it would help if I could spell correctly. We can see here that our application can't connect to SQL. So there's a couple of things. Our application is expecting secrets to be available in a particular location. It's worth noting here that when we do the sidecar pieces, what's happening is we're doing an empty dir volume in Kubernetes to share the secrets between the running containers. And that's an in-memory empty dir. So this data never hits disk. So from a security standpoint, I would say that's as close to a best practice as we can get in terms of passing secrets back and forth between the containers. But we can see here, like I said, we're not actually able to access any secrets here and our application doesn't work. And if I show you here what the difference is. So last year we did this demo where we've got this, Postgres client that's going to run on a loop. In order to get access to dynamic secrets, last year we kind of showed you using this sidecar deployment. So what we had to do was build a manifest that would not only have our actual client application in here, but also have things like the Vault agent sidecar to handle the login into Vault and retrieve a token. And then we had to run a console template container inside this pod spec as well. And this is what was rendering out the secrets, retrieving secrets from Vault, and passing this back and forth between this container and the actual Postgres client container. So we can see we've got to do a bunch of plumbing here. We've got to do shared volume here for the secret storage itself. We've got to define some volumes, including that empty dir with a memory backing, some config maps as well. So the important part here is we had to define config maps for the Vault agent and the console template spec. And those Vault agent and console template specs are pretty straightforward, but it's a lot of writing and it's a lot of manifests to manage. It's a lot of things to do. So this is completely the spec that we used last year. What we're going to do is roll out the new injection method. And to show you the compare and contrast to that spec, the prime difference you're going to see here in this spec is we don't have to define any other containers in our client spec. So all we've got is our Postgres client, all the necessary elements here for our actual application to run, but you don't have to do any of the Vault and console pieces that we would have had to do previously. We're doing the exact same secrets retrieval. We're running the exact same container. The difference is here, everything else we're doing is controlled via some annotations. So these are the same annotations that I showed in the presentation previously, but just to run through real quick, effectively, we're going to go and template out the Postgres secret itself for PGSQL to run. And then we're going to run another one here just for our benefit so we can see what's happening in the background. So let's go ahead and deploy this one and see what the difference looks like. So we're going to go ahead and apply our new one with the injection. So we're going to see our new app firing up. The biggest difference you'll see right off the top here is that we're now running 2 containers inside of here. So we've got now a sidecar container that we didn't have to define. That injection pod did this for us. We didn't have to go and define this in our Kubernetes manifests, and now our app is up and running. So if we go ahead here and just have a look at what's going on. And we'll notice here, it's asking now for what container we actually want to log into or get logs from. So in our case, let's just have a quick look here at our Vault agent init. So we'll look at that init container and I'll just show you kind of how this comes together. So this is that init container that runs to do the pre-retrieval. So it logs into Vault and we can see a successful login event here. And it also does the pre-render of the secrets. So we can see it rendering 2 dynamic templates and then running this arbitrary command that we wanted on our template to be able to use this inside of secrets as we move forward. We can have a look at the logs for the actual Vault agent sidecar. So this is running alongside of our application container to keep itself logged into Vault, renew the leases, and make sure that it's rendering or retrieving secrets and rendering the templates on a continual basis. So if the credentials change, this is the container that's responsible for rewriting that spec so that our application container can use it. And then we'll have a look at our actual client. And now we have successful login. So what I'm doing here is not something you would do in production in the sense that I'm spitting out a username and password here into standard out. But for demo purposes, it works pretty well. So the biggest difference here is we're actually rendering our username and password. We're rendering our PG pass string, and then we're doing this database query. And this is all this container does. Every 30 seconds goes and does a database query. The database itself is our Postgres database. And one of the biggest things we'll see here, we'll just do a quick refresh, make sure we're getting live data here. We're seeing a couple of service accounts that were created. One of these service accounts is due to the fact that we've got an init container. So it fires up first, gets an ephemeral service account. And then the next one is our actual sidecar. Now what's happening is this is Vault creating these service accounts. And Vault creates these service accounts with an expiry. So Vault knows how to track them and get rid of them when the expiry time is up. And then effectively, we've got the second one here as well. And we should see a mirror of this data when we hop over to Vault as well. So if we go into database, we're seeing our 2 secret leases here as well. And same for the actual Vault login, we can see those leases in addition. So in about 2 minutes-ish, one of these is going to expire. And this is on the basis I set all these keys and these secrets to be a 5-minute TTL. Effectively, Vault will expire these at the 5-minute mark. Our application container with our sidecar, the Vault agent sidecar, is going to do the renewal on the half-life of the secret or the half-life of the token, depending on what part of the equation we're talking about. So because I've set 5-minute TTLs on both the Vault token and the actual secret itself, we're going to see an activity in our logs here that every 2.5 minutes, it's going to go relog into Vault, get a new token, and it's also going to retrieve the database secrets. Just a quick side note on the actual dynamic database secrets here is we're not getting a new username and password every time. These are renewable secrets. So a commonly asked question in the dynamic secrets world with databases specifically is we don't necessarily want a different username and password every 5 minutes. And that's not the case here. We're going to keep the exact same username and password basically perpetually as long as we allow it from a Vault policy standpoint. But as long as we keep renewing, we're going to keep seeing the exact same set of credentials each time. And we haven't quite expired that yet, but that's okay. Now, one of the things we can do, I'll just do a quick login here. Actually, let's just do it this way. And what I want to do here is I want to show you what this looks like in terms of what the client sees. So the biggest difference here is, oh, I need to specify namespace. So one of the things we can see inside our running pod is we see a volume that's mounted. That volume is our empty dir, our in-memory empty dir vault/secrets. This path is customizable. We've made the application container here look for our secrets in this path, but ultimately this is what console template and Vault are rendering out for our database. So we can see here our PG pass file as well as our username. So this is nothing more than our actual secrets that we rendered out. And this is what our application container is using as a connect string to our Postgres database. And this maps up that DRU in this service account here. This maps up to the actual one that we see in SQL as well. So we can see this account right here. That's the account that's being leveraged by our application container. So easily trackable, and more importantly, perhaps, is easily revocable. So let's head into our actual Vault implementation here, and we got a little bit of a slowdown in Vault. But what I want to show you is an actual lease expiry. So we'll just tail the logs here, and then we'll do a lease expiry. So here's our logs here, and we'll go in. We'll go into auth here. Apparently, they were running into a little bit of a slowdown, but we should be able to get there. We should actually only see one login right now, which we're seeing here. So we'll go and, the scenario here is, case of a breach or, an expiry of a service account or, effectively we might not know when a secret was deployed and retrieved, and we just want to go brute force revoke it. So we're going to go ahead and revoke that. Once we revoke this, we're going to start to see some events in here in the sense that once we actually revoke it, Vault will go in because we revoked the actual Vault token. Vault is going to go and actually revoke the leases underneath that. So any leases that have been taken out on secrets by that token are going to consequently be expired as well. So this is kind of the heaviest handed version of what we could do to lock out secrets. But we're going to have a bit of a delay here too, because effectively Vault's got to go in and expire that secret within the database. And the interesting part about this one is we've already renewed it. So we can see here, actually, let me just Control-C it here. So we've already renewed. So Vault did expire the previous one, but in the time we were talking here, because I put these TTLs pretty short for the demo, is we've already actually got a new one. So if we go into our SQL database, we'll see a fresh one here. So a little bit of live demo fun where we set the TTLs a little bit too short to be able to showcase what I wanted to, but effectively you get the idea. We've got a new service account, new username and password combination. Database password rotation doesn't get any easier than this. And like I said, a big portion of this part of it is this comparison and contrast to how we get secrets injected into our Kubernetes apps. Is a much more streamlined process. It works extremely well, very hands-off, a few simple annotations, and you're off and running. That's all I have for my demo. So, feel free to stick around for Q&A. I think what we'll do is kind of kick off with the next demo. And yeah, like I said, team will be around here to answer questions. And thanks for tuning in. Off to you, Aaron.
All right, thanks, Tim. That was really, really, really good. These are pieces of Vault that I haven't even seen myself yet. So that's really good. Yeah, and just to reiterate, we're going to hold Q&A at the end and bring everyone on to answer whatever questions we might get. So up next, we have Jacob Mammoliti talking about using Transform Secrets engine with Go. And I believe he's even made a custom application to make this happen. So here is Jacob. And go ahead.
Thanks, Aaron. Yeah, so with this one, it was kind of an excuse to also extend my Go knowledge a bit more too. So yeah, this talk will be using the Transform Secrets engine with Go, which is a new secrets engine with 1.4. So I want to kick this demo off with a bit of background as to why using Transform and Vault in general can be crucial to your organization, your data, and to your clients or users. The bounty for user data these days is extremely high, and if it's stored in plain text, this allows attackers to easily read the data. Some big companies over the years have admitted to storing user data in plain text, including passwords, which makes a hacker's job a lot easier when they don't have to try and decrypt this data that they've now gained access to. With the internet being a massive part of people's lives, it should become second nature for us to enforce a high level of encryption of all data that is stored, especially when you're dealing with the data of your users. And even given the times now with everything, I find myself personally shopping online more. So it'd be reassuring knowing that when I enter in my personal information, such as like my address, credit card information, or even just like my name, that it's being encrypted before being stored persistently. So like I mentioned, with the release of Vault 1.4, which was a few weeks ago, we got introduced to a new secrets engine called Transform. And this was an engine that I was super excited for just because I've had conversations with customers in the past who are looking for something like this. If you're familiar with the transit engine, you'll be very familiar with the concept of Transform. It helps abstract encryption by providing a simple way for teams, or more specifically developers, to encrypt the data their application ingests and stores it safely. So in this session, I want to dive into what the engine can actually do, talk about some of its features, go through an example workflow, go through actually setting it up and talking about its core components, and then go through the actual live demo. So I'll bring up the Go application. We'll go through the code as well and just walk through the differences with Transform and Transit. So a little bit about me as well. My name is Jacob Mammoliti, a consultant at Arctiq out of Toronto, mostly focusing on enabling customers with HashiCorp tooling, so mostly Terraform, Vault, and Console. And then I also spent a lot of time in the microservices space, working with all things Kubernetes. Security has been a big interest of mine recently. And I've been working with a lot of customers on how they can improve security practices in general and with Vault. So we've been doing a lot of the stuff like Tim just talked about earlier, and some of the stuff that Marc's going to talk about as well. So you can find me on Twitter and GitHub with the handle that's under my picture, or also by email, which is just my first name, last name at arctiq.ca. So let's go into the overview. The Transit Secrets Engine is responsible for transforming data on the fly. In this context, transforming is a method of encrypting data with either format preserving encryption or masking. And these are two terms specific to transform. Format preserving encryption, or FPE, refers to encrypting data in such a way that the output ciphertext is the same format as the input plain text. For anyone familiar with the Transit Engine, it offers a similar service by taking in your plain text data and encrypting it with a wide range of key types, with the default key for Transit being AES 256. The major difference between these two engines is that Transform is able to preserve the format, like I mentioned, while Transit gives us a ciphertext of a completely new format. When we get to the actual demo, I'll show the difference of the two ciphertexts. So like I mentioned, I worked with a lot of customers who wanted to use Vault as an encryption tool for their data, and they loved using Transit. The issue that has always come up was the size of the ciphertext. In some events, their databases were already set to accept specific data types, such as chars or varchars with explicit data lengths. Because of the length of the ciphertext that Transit spit out, and it can't be controlled, this became an issue in some situations. Transform can come up and still encrypt the data and preserve the format, allowing encrypted data to be stored in a database with explicit data lengths. So like I'll show in the demo, if I input like a credit card, I'll get the ciphertext of the exact same format. Like Transit, Transform does not store the data it transforms. The idea is that a development team can utilize Transform to have their data encrypted and be assured that the ciphertext they get back is indeed meeting a high encryption standard. This now relieves the burden of writing proper encryption and decryption algorithms at the application level, and now pushes that onto the team that's owning Vault. The development team's task now focuses on sending plain text data to get encrypted and storing the ciphertext to get back to some persistent data store. Coming back to now how Transform actually encrypts the data, I just want to touch on it high level of what it's using under the hood, but also, like I said, I just want to keep it high level for now, and then I can take in questions afterwards about it. I mentioned it's using a format preserving encryption, which utilizes the AES-FF3 algorithm, where it uses a customizable tweak value to encrypt data while keeping its desired format. The other option with Transform is the masking option. Masking is non-reversible and does not allow reverting back to the original plain text value. So the next thing I want to show here is an overall workflow, and this is kind of a workflow where you have an actual application and you're using Vault to encrypt your data, and then storing it persistently. So when I show this diagram, I usually just like to give like an example scenario, which a lot of customers I feel can relate to. So let's pretend that we work at a company that has a Go application that is backed behind some database. Right now, you have a team of 3 developers that are responsible for working on your app and making sure it stays updated. Right now, 2 of the developers are using their own methods for encrypting data, by each using different Go libraries, and the 3rd developer isn't using any encryption at all. The problem with this situation is that there isn't any consistency. And when it comes to something like an audit of security measures, the spotlight is on the developers, which clearly don't have a great story. The other issue with this is that developers are focused on having to think about the type of encryption to use. And again, that is being done at the development level when it really should be done at some sort of security level. With Vault and Transform, developers no longer have to be responsible for this. Instead, they can just be given 2 API endpoints to hit, one for transforming data and one for decrypting it. This now allows the developers to solely focus on developing their application and do not have to spend time passing security measures, as this is now passed on to the operators of Vault. All security compliances can be met at the Vault level and can now be audited easily without having to dive into any of the source code. Having a look at this actual diagram now and walking through it, this is a workflow to transform the data that a Go application receives. And we're going to assume that all the communication with Vault and the application is all over TLS. So on the left side here, I have the play button logo, and it's going to represent our application. So this application sends its app data to Vault through its API and requests to have it transformed. Vault will transform that data and send it back to the application. The application can now take that data that's transformed, also known as ciphertext, and store it into some persistent data store. So again, this is removing any idea of entertaining any idea of storing data in plain text. Now, on the reverse side, when it comes to actually retrieving the data, a user can always request to see their data that has been transformed, and then the workflow would basically work in reverse. So the user would request that data, and the application will do a lookup by some sort of primary key and return the ciphertext from that data store. The application will then connect to Vault and send that ciphertext to Vault through its API and request to have it decrypted. Vault will decrypt that data using the key it used to transform it and put it back to plain text. It'll then send the send the data back to the application, which can then print it out to the user. As you can see, now with Vault, it becomes an integral piece of the application and the database workflow. One piece I did leave out was how the application actually authenticates to Vault, which can be done with app role, which is a different conversation. And again, that's something I can answer questions about after. The application I'm using actually uses app role as well, so I can talk briefly about it when I go through the code. So we've talked about kind of what Transform is, the overall workflow for it, but let's go through actually enabling it and setting it up. Like enabling any other secrets engines, enabling Transform is super straightforward. Everything in Vault is path-based, similar to how like a Linux or Windows machine is set up. So I've added a terminal on the left to show the steps which enable the secrets engine, creates a role, creates a transformation, and then transforms a credit card number. This is the simplest way of setting up Transform, and is the example provided by HashiCorp. However, we can get much more customized and essentially create a transformation for any data that we like. So we could do something like a passport number, a name. Really, it's up to you. So Transform is made up into 4 different components. There's the roles, the transformations, templates, and alphabets. So we'll just dive into each one and explain a little bit about what they are and what role they hold in the overall Transform stack. So a role is a basic level construct that holds the allowed transformations to be performed. It provides the same functionality as other roles throughout Vault. So if you've ever used the database secrets engine or a cloud-based secrets engine, you're creating a role. So it's the same thing with Transform. A transformation contains the information of the type of transformation we want to perform. The template that we want to use, and any additional encryption information that I mentioned earlier, such as a tweak or masking characters. A template contains the information on how to capture the value and determine how we want to transform it. By default, Vault provides a template for credit cards and social security numbers. If you want to use Transform for a Canadian passport number, for example, you would write your own template. And HashiCorp has an example of this process on their website on the learn.hashicorp page. The final piece here is the alphabet, which is a definition of valid UTF-8 characters that are to be worked with both input and transformed values. Vault provides some default alphabets, including numeric, alpha lower and upper, alphanumeric lower and upper, as well as alphanumeric, which is a combination of both uppercase and lowercase numbers. Upper and lowercase characters. This is really the only components that you need to actually get started with Vault. And once you understand these, you're pretty much on your way to start encrypting data. So now we'll get into the actual demo. So what I'll first do is I'll first go through the code here. And this is the Go application. And I'll show you what it looks like to set up your application to use Vault to encrypt data. So the beginning here, I'm just importing some data, I'm importing some libraries that I'm using throughout my code. And then right off the bat, I'm defining some global variables that I'll be using throughout the code. So stuff like role ID and secret ID is specific to app role authentication. So this is how my app actually authenticates against the cluster, the Vault cluster, to be able to go encrypt and decrypt data. These are all environment variables as well. I'm setting the Vault address as the environment variable as well, just because I want to limit how much I'm hard coding. A big benefit with using Transit and Vault in general, Transform and Vault in general in your applications is it helps alleviate a lot of the hard coding that you would typically do in code. There's been a lot of situations where I've seen developers actually hard code database passwords or something like that in their code. Or as an environment variable, which provides really no audit trail. So Vault is a huge piece in securing that up. And then I'm just defining a few more paths here that I'm using throughout my application. So from line 24 to 39, this is the function to actually go log into Vault. I'm just using some logging to print out what we're actually doing, so we can tail the logs to see what's happening. And then we use the Vault library to go log in with our app role credentials, and we get back our token. When it's done, we just print out that we successfully logged into Vault. The next piece is a function which is actually doing the transformation. So what we're doing is we're inputting our credit card string as well as the Vault API client. We're then going to go ahead and write to our transform path and get back a secret which will contain our new transform data. The next piece is our write function, where we take the transform and actually write it to a file. And again, this could be written to anything persistently. Just for the demo, though, I was just writing it to a text file, but you could do something like a database as well. The next function is transit. So this is using the other secrets engine that comes with Vault. And the reason why it basically does the exact same thing as transform in terms of the Go code, but I wanted to put it in here as well in the demo to kind of compare the two and see the type of ciphertext you get back with each secrets engine. The next one is the write data function, which we talked about a bit earlier, where all this is doing is it's taking in the data that is now encrypted and storing it persistently. And again, we're just using a file for this example. Our next function here, again, not really related to Vault specifically, but this is more just the ability to read the data in the file, because for our application, we're printing out all of the data that we've encrypted so far. The next function here is just a landing page, and this is the function responsible to fire up whenever we hit the root of our web server. And this is just handling different types of requests. So anytime we do a post request, so we're either submitting a form for transform or transit, this is the logic behind here as to which function to hit. And in here, we also have the method of logging into Vault. So every time I submit, I'm logging into Vault with my app role credentials, going ahead and do what I need to do. And then at the end, to keep Vault tidy, is I'm actually revoking the token. This would expire by default. This would expire eventually based on a TTL that Tim talked about earlier. But just to keep Vault tidy and not to have that lease hanging around, once I'm done with it, I can essentially revoke myself from logging back into Vault. So if I needed to log in again, so say I want to resubmit a new piece of data, I would have to re-authenticate to Vault. And then the final piece here is just our main function where we actually call everything. So we declare our Vault config, we create our new client, and then we just have a wrapper function here that's using a handle function that listens on the root directory, and we call our landing page function every time we hit the slash on our web server. And then we start up our web server and just have it looping until we Control-C out of it. So let's go over to the application here. So it's pretty straightforward. It's really just a simple form. And really what we're just trying to highlight here is the credit card number. What we can see is if I input my name here and then put in a sample credit card number, I'll just keep it consistent. And then I hit it with transit. So this is the old secrets engine that came with Vault, and it's still active. It still has obviously tons of use cases, but this is what we were using before. So we submitted it with transit, and and now, just give me a sec. My VPN disconnected, so try connecting again. Let me try refreshing this now. Okay, well, this doesn't want to come up. Okay, what I can do is...
the demo gods will work with us, Jacob.
Yeah, I know. Just give me a sec while I try to get this back online. For some reason, my OpenVPN application crashed. So just give me a second. Once this is back online, there we go. I should be able to refresh this page now. I want to do it just a GET request for now. Okay, there we go. All right, so let's try to do this again. Again, we're going to put in our credit card number. So when we did it with transit, we see we get back this encrypted value. So looks very encrypted, right? By default, it's using AES 256. So obviously, this is not something that someone can just take a look at if they ever got into your database or something. This is what an attacker would see for a credit card number. So really, they have no real way of decrypting this value unless they somehow got access to the key that they use to encrypt it. And like I mentioned, the issue with this is what I had the feedback from some customers is, well, my database field for a credit card number really is expecting the same format that it inputs, right? So it's really expecting this to store it. Anything like this, the database won't accept it. And this is just because of an explicit length they've set on the data in the database. So now when we use something like transform, we can go ahead and input that credit card number. And now we've gotten back a new encrypted data that actually matches the input that we put in. And again, this works for anything, right? I can go ahead and do like a different credit card number, and we're going to see that we get back a credit card number that is completely encrypted. And then the only really way to decrypt it is, again, to use the same endpoint. So let's take this one, for example. We'll head back over to my VS Code here. I can go ahead and now so I'm already logged into Vault here. I can do a Vault write on the transform decode payments path. And this is the same as the actual encode, except the only difference is instead of encoding the data, we now want to decode it. So I can go ahead and paste that in here. And we see we get back the original value that I submitted. And this, again, works the same way with transit as well. You have to use the same key and the same endpoint that you use to encrypt it to decrypt and get the same data back. So that's what I had for the demo around transform. If there's any questions, like I said, follow suit. Just post them in the YouTube chat, and then we'll answer them after Marc's demo at the end.
Great, thanks, Jacob. That was also very interesting. Concepts of using transform instead of typical encryption are definitely out there. We know how many companies have had breaches related to credit card numbers in the past year, so it's an interesting topic. So up next, we have Marc LeBlanc, and he's going to be talking about dynamic secrets with Vault and Terraform Enterprise.
Dynamic secrets with Vault and Terraform Enterprise. So today I've got a bit of a talk and a demo showing how we can use Vault's dynamic secrets engine for GCP and making that a consumable artifact for Terraform Enterprise. Not really an artifact, but a secret rather. So where's that JSON file? So when we're talking about automating within GCP and using language such as Terraform to do that provisioning, one of the things it requires is a service account in GCP with the correct roles and permissions on the various resources in your environment. The way that traditionally we've called upon that service account is through a JSON key file. This becomes kind of a cumbersome thing to manage. It's a physical file that needs to be downloaded. It has to be distributed to the right people. It has to have those keys rotated on a regular basis. It's just kind of a task that there must be an easier way. So the easier way that we're going to show you today is using dynamic secrets from Vault. So who am I? I'm Marc. I'm one of the consultants at Arctiq. We're a services-based consulting firm out of Toronto. I do a lot of work with customers looking to do automation and get onto the cloud. It seems more often than not I'm using HashiCorp tools such as Vault and Terraform and working in GCP. So that's kind of where this talk came from. So some of the benefits of using the Google Cloud Secrets Engine, it's an automatic cleanup of those keys that I was talking about. They can be created with a short-term access through a time to live. So I can create a service account key and it'll exist only for a few minutes, enough time for the job to be done, and then that key is terminated. Obviously as well, another nice thing is that it has multi-cloud and hybrid cloud applications. So one of the concerns that comes up when we start talking about service account keys is just kind of what I was talking about before, is it needs to be manually managed traditionally. So security teams, when they get involved in the discussions, they get very concerned about how they control who has access to those keys, how long those keys exist, what permissions those keys have. So by using Vault, we kind of help address a few of those points right away. Number one, there's no keys that are actually ever physically distributed to any one user. That's just not a thing that needs to happen. It's all done programmatically through Terraform, and only Terraform ever actually has that key for a short moment in time. The other thing that we gain by using Vault is we have a central location to manage all the roles that are applied to that service account, rather than having to navigate through GCP and go to the different resources and apply the correct IAM. You have a central spot just through the role set that's created through Vault. And we'll take a look at how that kind of works in a moment here. Okay, so first up, how do we enable the GCP secrets engine? Super easy. All the steps are kind of right here. The first thing you're going to do is you're going to do Vault secrets enable GCP. That's going to create the default path at GCP within Vault. Next thing we need to do is we do need to create a single service account that Vault uses to make those calls back to GCP, to create those IAM, to create those keys, to create the service account. So it's a very limited scope service account, and it is only accessed by Vault. And so you can see that on the second line there. We actually write that credential file to the GCP config. The last step of this, for this demo anyway, is I've created a role set that's going to be consumed by Terraform through a module called Project Factory. Now I like referring to Project Factory because it's a nice kind of project intake Terraform module for GCP. It bootstraps the creation of the project. It can enable some APIs. It can do things like create the default service account. So I've created a role set here that has those kind of capabilities. And what I've done is I've limited to only be able to create projects within a test folder in my GCP. And again, we'll take a look at this in a minute. But this is the command to create that role set. So you can see that I'm creating a role set at the path GCP with the name Project Factory role set. And I'm restricting it to a project called LHQ-Vault demo. This is where that service account is going to be created. We've given it a secret type of service account key. That's just because typically we use the service account keys within Terraform. You can also request a token, but for our application, we're going to use the keys. And the last thing is we're referring to a HCL file that has all the various resource bindings that we want to have applied. So for this demo, what we're going to do is we're going to talk about, take a look at that service account that Vault is using. We're going to take a look at the bindings that are being requested for the Project Factory role set. We're going to take a look at how those APIs for a project are being requested. We're also going to look at how we can provision a project, but also associate it with a service account that has the ability to provision within it. And then lastly, we're going to actually provision a GKE instance in a requested project. So I'm going to move along to the demo now. We're done with the slides. I didn't want to do too many slides because I think there's lots of good stuff to show you. So the first thing I'll talk about is that role set for Project Factory. Now I showed you the kind of one command to create it. This file here is the HCL file that has the resource bindings. For this particular account that I'm creating, it's got access to two different levels of things. It has some functions on the organization level, so it can be able to associate a new project with a billing user, and it has some ability to see some things within the organization, but that's it at the organization level. The other level we have applied things is at a folder level. Now, I just happen to know that this folder ID here that I've highlighted lines up with a test folder within my GCP organization. It gets some kind of project bootstrappy like roles, folder viewer, project creator, service account admin, and project deleter. So it can create projects, delete projects, and create those service accounts for them. And if we do a Vault list of our role sets, we'll see that one exists. And it's right here, Project Factory role set. So great, so what does that mean? Let's hop over to the Google Cloud Console for a moment, and I'll show you kind of how that comes about. So in my GCP organization, I have what I'm kind of referring to as a control project. This LHQ-Vault demo is going to house all the service accounts that I'm creating. It's going to be the project that has the Vault service account that gives Vault access to GCP, It's going to house that project factory service account and any of those project-specific service accounts. That'll be clear as I kind of go through some more of the demo, but let's just drill down in here for a moment. There's a few default kind of service accounts that exist right away, but two that I want to point out. The first one is this one here, Vault A. So this is the service account that Vault is using. Notice it's the only one that actually has a key right now. It's been around for a couple of days. I should probably get that rotated, but the point is this one exists so that Vault has access to GCP. This service account has access on this project and that test folder because that's kind of where I want Vault operating. Next service account we see is this project factory one. It's given a kind of a random name. That's okay. It doesn't really matter. I don't really care that it has a random name because I'm never going to be referring to this service account by name, but rather by that Vault rule set that we've created. And what I mean by that, if I pop back over to my console window here, this is the rule set name that I'm referring to. All right, moving along. So I mentioned that we're going to do some work with Terraform Enterprise. I have 3 workspaces within Terraform Enterprise. So for anyone that's not familiar with Terraform Enterprise, it's kind of one of their UI interfaces to more enterprise-grade Terraform runs. I have 3 workspaces created right now. The first one we're going to talk about is Projects Control. Now what I have here is Projects Control is connected to a GitHub repo. And within that repo, what I do is I check in Terraform code that requests a GCP project. When it sees a new merge onto the master branch, it's going to be automatically picked up and trigger an apply. On this workspace, I create some variables because I don't want my developers to have to memorize things, or I want them to take some things for granted. So there's 2 sets of things that I have applied for variables. The first one are variables that are consumed directly by Terraform. I have to refer to these variables by name in the Terraform code. These are sort of some typical GCP setup things. So this is my organization ID. This is that folder ID for that test folder that we're going to deploy it into. And the billing account ID. The last thing that I want to point out here is Terraform Enterprise is connecting back to Vault using a token. There are some other ways to do this in a production environment, but for my demo, I just have an environment variable marked as a sensitive entry, and it gets picked up by a Vault provider in my Terraform code. So that's kind of the workspace setup for the project. Let's take a quick look at the code for how that works. So I have a project request file here called demo beer project. You can see we're requesting a project name. We can see here where I'm calling out those specifically named Terraform variables. We can see that I've requested a couple APIs, specifically compute and the container API for Kubernetes. And then the other thing that I want to point out is here's where we're requesting a new role set. So I mentioned that I'd like to have this provision a specific role set that could be used by the project to then go back and provision things, but in a fenced-in area, so they're only referring to their own project. So let's just point out a couple things here. Recall that previous HCL file I showed you for Project Factory. So this one, we can see that the resource that I'm binding it to is specifically that the same project by the same name. And I'm giving it the roles of compute admin and container admin and service account user. So it's very limited scope. There's not a whole lot that this role set is going to be able to do. So the 2 things, the 2 outcomes out of this Terraform code are 1 is the project with those APIs enabled, and 2, a Vault role set. So I'm going to kick that off. Now, I'm checking this directly into master. Obviously, in a production scenario, you'd have this go to a different branch. The approval would become a pull request, and you would see it be picked up by Terraform Enterprise. But to maintain my sanity while I pretend to be multiple people, I'm just checking directly into manage the master branch. So if we flip back to Terraform Enterprise into that project control workspace, we can see that it's picked up that commit. And we're not going to watch this all the way through. We're going to skip to something else, but I want to show kind of how this works. So I've committed this in. It's doing the Terraform plan. Make sure everything looks good. Sometimes this can take a moment or two to come up and finalize. But while we're waiting for that, let's just take a look. Starting at the top here. So what is it going to build? So the first thing we see that it's going to create that role set in Vault. Second thing we see that it's going to actually use that project factory Terraform module I was referring to. It's going to create a default service account. That's a project service account. Next thing it's going to do is it's going to actually provision that project. Next thing it's going to do, create the service account. One is the definition, one is the creation. Next thing it's going to do is make sure that any of the preconditions for that project factory module to run are taken care of, and some other bootstrap sort of items. So it's going to add 10 things, 0 to change, 0 to destroy. There it goes. So the plan's finished, everything looks good, it's green. I can confirm and apply it. Now, before I run this, I want to actually pop back one moment into GCP. And if I look at my project structure under test, right now I just have a pre-provisioned project, a wings project. So I thought a bigger project would go nicely with some wings, just to show that there's kind of nothing there. So that's the current state of GCP. Let's flip back to Terraform Enterprise. Confirm plan, and away it goes. All right, so while that's running, the next thing we're going to do is we're going to make use of this demo wings project that I have pre-set up. And we're going to use that to provision a GKE cluster into that project. So back in Terraform Enterprise, we'll let this run. This takes a few minutes to provision the project. We're going to switch back to the workspaces for a moment. And we're going to flip into this GKE Wings workspace. Now, one thing I want to point out, actually, before we do that, you'll notice that it points out the repo. So one thing that I really like with Terraform Enterprise and being able to set the variables at the workspace level is you can make a many-to-one relationship between workspaces and your GitHub repos, making that repo becomes a very standardized bit of code for your enterprise or your business. So in this example, I'm using the GKE demo. We're going to use it twice. We're going to get 2 unique GKE clusters based on the same repo without having to make any code modification in that repo. All the modification is happening via environment and Terraform variables on the workspace level. Okay, let's go into this GKE Wings project for a moment. Now, if I go into the variables, again, there's 2 sets of things set. There's the Terraform variables, kind of self-explanatory. What's the project name that we're working within? Well, we're working within the demo, the Wings demo, and the cluster name we want to give it is Wings GKE cluster. The other thing we're doing for the Vault provider, which I'm going to point out in a moment on the code, is I've specified the Vault address, and again, we've got the Vault token. Okay, so what does that mean? Let's pop back into the code for a moment. Moving along to the right. So this is my provider file for requesting these GKE clusters. You'll notice 3 kind of components here. Number 1 is the Vault provider. Now notice here, there's no definition other than it's being requested. That is because when this is picked up by Terraform Enterprise, it's going to pull the address and the token environment variables and run it that way. So that's where it's going to get that information. Then what it's doing is it's going to read a GCP key that's tied to that role set. So when it reads the role set for that project that is tied with access to that project, it is going to get a service account key to use. That information is then passed down to the Google provider. So let's just list those out again, and you'll see what I'm referring to here. So here's the one I'm referring to, Arc Demo Wings Role Set. We can see that it's going to be passed in the project name dash role set. Okay, cool. Let's flip back to Terraform Enterprise and recall earlier I mentioned that these runs can be triggered by commits to a master branch. If Terraform Enterprise is watching that branch for this workspace, we're going to trigger a manual apply because we're not making any changes. That's kind of the beauty of the many-to-one relationship that we can show here. So same thing, it's going to do a Terraform plan. Much quicker, much less to add. I'll just do a quick sort of check about what it's doing. And you can see it's making some requests for some GKE sort of standard stuff. Much quicker, comes up, it's ready to be applied. Okay, cool. Let's go ahead and confirm and apply that. Confirm and apply. Now, what I'd like to make sure people are remembering here is normally to do this, I would have to create and download a service account key manually from GCP. I have not once done that as part of this demo yet. So that's off and running. That takes a moment. It has to create a VPC network. It's going to create the GKE cluster. While that's running, let's flip back to our GKE. And I'm actually going to just refresh that. And at this point, if I browse down to my test window, we can see that there's a demo beer project and a wings demo project. That's great. And what I want to show, another thing I'd like to show is what happened. So we created that role set for the beer project. And if I navigate down to that project and I take a look at the IAM for a moment, and again, for those familiar with GCP, understand that IAM is inherited from top down. So that's why we see a lot of other inherited items here. But what I want to point out are these sets of IAM here. So this is a service account that has been created. It's created, and I just know from the format, it's created in this LHQ Vault demo project. And it has those roles that we requested be created as part of that project provisioning. Compute admin and Kubernetes engine admin. So that account has these permissions on this project only. Very similar to what's happening, it's identical to what's happening with the Wings project right now. So if we switch back to our Terraform Enterprise, just about done. I suspect if I pop into that GCP project now, and if we navigate down to the Kubernetes clusters, I bet we'll see something. And we see that it's still provisioning. Very cool. Final thing I'm going to kind of show, I want to pop back up to this Vault demo project. I'd like to come into show you the service accounts. So we can see a couple things here. If you recall at the beginning, there was no keys in some of these projects. So Vault has gone in and automatically said, hey, give me a key for these accounts. The first one was for Project Factory. This was the key that was used to provision the beer demo. The second one that was requested is for the demo, the Wings demo. That was the one that was used for provisioning the GKE cluster. The last account that was created is this demo beer account, but we haven't used it, so there's no keys yet. If we made a request to run that beer workspace, we would see that it would request a key there as well. So again, that's kind of the demo in a nutshell. It's just showing a couple different ways that the dynamic secrets engine for GCP and Vault is being consumed by Terraform Enterprise. This is one approach that could be implemented. It's kind of really cool stuff. I hope you've enjoyed the demo. Apologize I wasn't able to be on the live stream that we tried to do earlier. But if there are any questions or comments, please drop them in the video feedback and we'll get them answered for you. Thanks.
Hey, everybody.
Hello.
There we go. Gotta love the live demo gods here.
Yeah. I mean, we're also at the mercy of, whatever the internet's going to give us today. So we didn't pray enough to the demo gods, it seems, but that's fine. We do have a few questions to cover, which is good. We have some that are pointed and some that are for anyone to answer. So for Jacob, I have one for you. What would be a use case to use masking with Terraform? Transform.
With Transform. Yeah. So I touched on masking briefly. I think where I see the most use cases for using masking, I think Hashi talked about it as well, is if you need to work with like sample data or something. So for example, if you need to pass a bunch of data that your users have submitted maybe, but you want to test with it, but obviously you don't want to use their actual data, masking is a good option for that, where you can just basically send a bunch of plain text data at once to get masked. And now all that data is encrypted. And then the difference with masking, like I mentioned, is that you can't decrypt masked data. So once it's masked and it's now encrypted, that's basically it. So it provides an extra level of security that you can essentially send that data to somebody, knowing that there's no real way that they could attempt to decrypt it.
Okay. We have another one that I think is similar in topic, so I'll go to that one too for you. Is Transform still using a selectable cipher key, like a typical encryption method?
Yeah, so it's a bit different, like, and maybe this is similar to like transit. So transit, you can actually choose different types of encryption keys. With Transform, it's a bit different. Vault uses, like I mentioned, the AES FF3 encryption method to encrypt that data, and right now that's the only way to encrypt that data. So it works a bit different compared to something like transit, where transit you can actually choose, like if you want to use like AES or RSA or something like that to encrypt your data.
Okay. All right. Very good. Thanks. We have one for Tim. While managing applications, what would a developer role look like in terms of managing secrets with dynamic injection?
Yep, it's a good question. I mean, it really kind of depends in the sense that it really depends on how much in the Kubernetes side the application teams are managing. But ultimately, one of the things that I find is, where Kubernetes starts to become complex is when we require developers to do too much of the customization. So like what I showed in, sort of the contrast to last year's event around having to, plumb sidecars and think about volume mounts and all that sort of stuff. The trend forward is really trying to eliminate that frustration, eliminate the dependencies that are required. So ultimately, the application team or developer's role is making sure that a container spec is written in a way that can leverage secrets the right way, but allow something else like this injection method to actually handle the loading of the secrets so they don't have to think about it. Ideally, the more friction we can remove from ingesting secrets in this way from an app team perspective will kind of enhance that experience and kind of drive more app teams to think about a security first approach, right? And not necessarily be thinking of Kubernetes secrets as secrets.
Okay. I guess I'll follow up with that. I mean, would operations people benefit from, similar dynamic injection?
Oh, absolutely. Absolutely. I mean, at the end of the day, this injection method could be leveraged for any containerized app inside of Kubernetes. So, at the end of the day, if that's a more operational focused tool that needs access to particular secrets, then, that's a very applicable use case, right? And more we're seeing operations teams adopting Kubernetes for operations focused workflows. Kind of the perfect sort of merging between sort of two paradigms.
Yeah, for sure. And we get to use the word DevOps now that we covered both sides.
I think that's what it means.
Yeah. I have another question. How much of what you demoed today would be able to be done from the Vault UI, or for those who are partial to CLI, should they just stay there?
Yeah, that's a good question. I mean, there's a few things that could be done as a part of the UI, although I don't think you're going to find a very good experience in terms of being able to tune some of those backends. Specifically, things like dynamic secret retrieval and things like that. Those are all either CLI based, or the preferred method in general is API. So normally our recommendation would be to automate a bunch of this stuff through the use of something like Terraform with Vault as a provider. And effectively controlling Vault policy, the secrets engines, volume mounts, all that sort of stuff from the perspective of Terraform. So, kind of easing the burden of that, while not necessarily driving to a UI. I mean, a UI is still kind of a point in time thing. And I mean, I showed it to do lease revocation and that sort of stuff, because that's in general where I'd point people to the UI, or just standard maybe KV secret store, that sort of stuff. But for application-focused workflows, generally the recommendation would be to fit it inside of some form of automation workflow, whatever that looks like for you. You are muted, Aaron.
Oh, thanks. I was muted. Couple more questions we have here for Jacob. Can Transform or Vault use external systems for entropy? I'm guessing things like HSM or yeah.
Yeah, for sure. No, it's a good question. I think that question actually comes up a lot. And I know we've talked about it internally too about that. And it can, right? So Vault as a whole can use like an external HSM or something for entropy. And Transform is no different. So if you wanted to use like an external system to get like a higher entropy, you definitely could use something external as well. No, you're not limited to the system that Vault is actually running on.
Okay. There's another one here. Is there yet a hub of common Transform templates for those who don't want to write them?
So there's a couple that HashiCorp released already. The one is for credit cards, and the other one is for I want to say it's a passport. I can't remember off the top of my head. Those are the two that I've seen so far, just because the Transform engine is new. Like it got released with 1.4 a few weeks ago. So I haven't seen any yet. But I mean, I've definitely wanted to get into writing a few more. So, but at this time, I haven't seen like a main hub with a bunch yet.
Okay. We have another one here. Is Vault dynamic secrets functionality compatible or usable with MS SQL or Oracle databases? I don't see why not.
Yeah, so a while back, I'm trying to think, this might be a couple of years back, Vault shifted focus from specific database implementations to a generic database secrets engine. And so the idea behind that is you provide the template required in order to connect. So you're telling Vault how to connect. So, for the ones that are supported out of the box, there's some examples. And then for anything else is something where you can provide a custom connection string to basically have Vault configured. So as an example, if you want to flip over to a screen share, Aaron, I can kind of point to that in some of the code here. So let me just show a little bit here.
Yep, you're live.
Cool, thank you. So a little bit of the behind the curtains sort of stuff. Let me just get the right README here. So the idea here, when we look at something like the actual configuration of the secrets engine for Postgres. So I'll show you here that the Postgres side here, we're defining a plugin. So these plugins are the standard plugins from Vault, which I believe Oracle is in there, and I'm fairly certain MS SQL is in there. Postgres and MySQL are pretty easy ones off the top, but the idea is you provide the plugin name, then you're providing the connection URL. So this is describing to Vault how to connect to the database. And then the next important sort of part here is the creation statement. So once we define an actual configuration, we're telling Vault how to actually create user accounts, so those ephemeral accounts. So the important part here is you can kind of customize the access levels for those accounts. I'm kind of giving a little bit of, let's call it too much permission to the accounts that are getting created here. This is something that could be limited to particular databases and more tightly scoped than what we're doing here in a demo. But this is where I'm saying we've kind of deviated from the specific database by database configs or vendor by vendor configs and go into something more generic and customizable.
Okay, there's a couple more questions we have here. Oh, there's Jacob again. It's not only rural internet that's holding us back here.
What worries me is I'm in the heart of downtown and I still can't get solid internet.
Right, eh? So another one here, is Transform a convergent encryption mechanism?
Yeah, it is. So out of the box, it is. And that, so if I encrypt the same credit card, I'll get the same ciphertext back. Again, this is similar to like what Transit can do as well, as you can flick on like a convergent flag, which essentially did the same thing. But yeah, by definition, with Transform, it's the same thing too. It's convergent.
Okay, very good. We have another one here. Can the Vault secrets path for sidecar injection be customized for each secret?
Mm-hmm. Yep. So the injection method, the way it works is you could specify any number of secrets in different paths. So I've got here like database creds read only. This could be a path for a KV store. It could be a path for another dynamic secret. It can kind of be anything. The idea behind it is that secrets can be kind of mixed and matched. So you can pick and choose any secrets and the locations where they come from. The part that is singular in this configuration is the auth method. So we can't authenticate in multiple ways, which I can't really see a use case where you'd want to do it. If you needed access to a couple of policies, I think you would simply make the role in the Vault side applicable to a couple of policies so that when I auth to it from this account, I'm attached to the right policies based off the secrets I need. And then each of the secrets I need an injection for, I can put it in this way. The other option here is instead of defining the templates here in line with the annotations, we can load this from config map. So we can provide these templates via config map instead, which can sometimes be handy depending on how in-depth the templates are. I mean, I showed just a couple of simple basic templates. And then the only other component I'll highlight, I don't think I'm sharing my screen, Aaron, if you want to throw mine back up there. Yep, perfect. Thank you. So the idea here is that I'm telling Vault what secret I need, and then you'll notice a naming convention. I'm looking for exactly the same secret twice. So I'm defining the secret once here, and then with that same secret and same endpoint, in this case, pgpass or .pgpass, I'm now specifying a template. So that's the only sort of restriction, is there's a one-to-one relationship between the secret and the template. If I don't define a template, basically Vault is going to write out, or console template is going to write out the template in a raw format effectively. So if it's multiple KV values or something like that, it's going to write it into the format that it's going to write it out in, which is essentially a map. Whereas in our case, we wanted to customize it and build a template that would pull out the secrets that we would need.
Okay, sounds good. Thank you, Tim. There was one more. Oh yeah, what song will you be playing on the piano for us today?
Well, I wish for one I could play piano. I wish for two that this was a real piano.
Yeah.
All things being virtual, that's not the case today.
Mm-hmm. All right. So this has been very good for everyone, I think. Unfortunately, we couldn't keep Marc on for his live stream, but what we'll do, everyone, is we'll take a video of his demo, put it on our YouTube channel. So feel free to subscribe and click for notify so that you can be notified when we put that up, or just keep an eye on our YouTube channel. There's plenty of content in there to look at. As for where you might find any of the code that we do for stuff related to Vault, you'll see it in our GitHub, which I put up here with the link. And then if you're curious about Vault, their website's up there as well as their GitHub. So for the open source components, and our website has tons of other blog content that people would be interested in reading, both on Vault and everything related to Kubernetes, cloud native things, and all that fun stuff that we do every day. So if there's anything else for Jacob or Tim to add, we're about to wrap up.
Yeah, the only thing to maybe add to that, Aaron, is just the in GitHub, have a look for the community-events repo is where the particulars for this event will be stored. So
Yeah, we have it's a /community events repo. If you look inside the Arctiq team GitHub, you'll see the repo in there as well. That's a good point. So thanks everyone for giving us questions. This was very thorough for us this time, and this has been great. Everyone have a great rest of their day.
Thanks, everyone.
thanks, everyone. Take care.
Take care.